Does it matter with physical classes in blended learning or without in a full online learning for undergraduate programming course in the pandemic situation? Now, to make it clear, this is not a survey paper. That is why I wanted to share this with all of you, how you can use your own course and then get whatever you can and then publish an education paper in a Scopus status, in a Scopus journal. Now, before I continue on, I want all of you to think about this. A lot of survey that we went through was that there was no online learning before the pandemic, which is not true. All of us have been using eLEAP, and then although it is not a recorded or not a video, but it is still considered partially as an online learning, or what we call as blended learning. So now before I continue on, let me share the poll first. So what would you people think? Do you people think that there is no physical learning? So will it work? Will it work? Will the student be able to learn? Now let me open up the poll now. So all of you can all of you see the poll? Let me see. I click OK first. Can you people see the poll? Okay,
Yes,
I see people start voting already. Thank you. Okay. So first of all, so you are a lecturer. So do you think if there is no physical class, there is no lecture, there is no lab, physical lab, do you think your student can perform? And then the second one, if you can assist student in their programming, what would you do? You can just say like one word or two word, things like that. Now, let me see. I have 9 people now doing it. Okay, I'll just give a little bit more because there are still 4 people in progress. Right. Okay. Now let me share the results, the poll results. Okay. Can you all? No, I need to apply first. Okay. Can you people see the results?
Yes.
Yes. Okay. All right. Now let me show in a bar graph. Okay, all right. So most of you actually said depends. Okay, now let us take a look because the one before this, I told all of you it's not a survey, but it is based on an actual results. Let me go back to my slides now. Now, this is old story already. COVID is over. We are now in the new norm. Okay. Now, what happened now? I want to highlight is that e-learning here. Now, Professor Fauzia from UUM, she is supposed to be heading this COVID survey or some on education for the ministry. Now, the e-learning here stands for emergency learning. In a normal environment, when we talk about e-learning, it's a gradual process. There is procedure to it. There are things that we need to follow. However, when COVID hit us, it was an e-learning or what we call as your emergency learning. Now, let us look at the literature review first. Because if you want to submit a paper to a education paper, the terms now makes a big difference. Blended learning, what is blended learning? Blended learning is a combination of conventional teaching and learning in the classroom with online component. Now, let us look at, is there no survey done on this? Now, face-to-face students perform better than their classmates who use online learning in their class discussion. So very careful. This is class discussion. So face-to-face is actually better based on Chen, Ke, and Chan's result. Now, Shu and Gu found that classroom interaction face-to-face have more interaction than in online learning mode among students. Again, it is the student interaction. When we have face-to-face, what they are looking at is the face-to-face interaction, the in-depth of the interaction. Now, what happened in 2013 by me is they actually provided evidence that performance based on grade is independent of the mode of delivery. So what is this person comparing? Is comparing between classroom and online learning. But at that moment, whether we can accept that results that no physical learning is actually better, that was a different result compared to what we have today. Now, not much difference is observed in web-based learning versus land-based learning. You say in 2012 and 2013, there were a little bit of evidence. Now, for what we have done is, just to make it clear, because this is a education paper, your methodology does make a difference. You have to be very clear. What we have done before the norm is, there is a blended learning in Java programming. We have physical face-to-face class, such as lecture and lab. However, all the rest of our online resources are put in eLEAP. Now, when we talk about online learning resources, there is the pedagogy behind it. There is the passive learning, there is the active learning, there's all these beautiful terms. In those times before COVID, eLEAP is only used as some place we park and then they just download. It was a one-way street that time. But when, during our emergency learning, we have a full online learning. So we have what we call as asynchronous online learning. Now, what we have done for Java is that we have interactive videos, we have interactive lesson, or what we call as active learning. Later, I'm going to show all of you active learning, which all of you are using it. So I want to make it very clear that I don't want it to be a tool-based, because I want you to gain something from here. If you want all these tool-based, you can search online. Again, we do have synchronous online learning, okay? A live type of lecture, and then again we do have the passive type lecture notes, and then more active type, like we have 1 hour online chat with the student, online discussion, and then where we assess students, we use quiz. So how does the interactive video looks like? This is how it looks like. The video will go on until some point, and then you will ask the student question. Then the student will have to just to assess them, or just to make sure that they understand. And then in our online discussion, if you can take a look at this, the student would go to their lecture notes, and then they will ask, what is actually a lexicographic ordering? And then the lecturer would reply, provide the sample, request the student to copy paste the codes in order to understand better, modify the codes and things like that. So this is the methodology, is what was done before and then what was done during the emergency learning. Now, again, that is clearly to state in your paper what you have done for your experiments. Now, what is this experiment all about? Again, it has to be stated clearly. The number of students is 270. Where is it conducted? Undergraduate, the Faculty of Computer Science in UNIMAS. And then within what semester? And then there is one particular requirement. It must be taught by the same lecturer. We didn't know this at all, but luck was on our side. So what this education paper looking for is, we don't want any random lecturer to be teaching, or any random teachers to be teaching and say that, oh, this group actually performed better. No, that is something that they would reject the paper. Now, what we have done for test 1 is, because COVID hit halfway in the middle of mid-semester, so there was a normal assessment, we use quiz. So after that was test 1. So test 2 was, we started the asynchronous online learning. Just right after the pandemic, not long after that, a few lectures, we had the test 2. Test 3, meaning to say, it wasn't suddenly, the student didn't get shocked at all. They already start to pick it up. And then we had more asynchronous, and then more asynchronous, and then we had the test 3. So actually, what are we arguing here? What are we looking for? It has to be really clear. There is no change in the average difference in the students' test result from blended learning with physical face-to-face classes to fully online learning. So I want all of you to digest this for a while. I know just now somebody actually answered no. So whoever you are, this you might actually be right, you might actually be wrong. I won't say, okay, the word wrong should not be used at all because it really depends. It really depends. Okay, so apologies on that. Again, digest carefully. There is no change in the average difference in the students' test result from blended learning with physical face-to-face classes to fully online learning. Now, this course was actually taught by Emilia, Irwandi, Dr. Alam, and then myself, and then staff. Now, Dr. Alam didn't want to participate, but we have to give him the credit. Now, why Sarah appeared was we needed a statistician. In this case, we don't have that strong of a statistic. So if you want to do paper like this, you must go and chase after one of the statistician. So here we can only reject this, or there is no such thing as accept. Before this, I also didn't know I used the word accept. Statistician said that use the word fail to reject. So here our target now is to reject or fail to reject. Let us look at the student's result. Now the student's results here, this is test 1. Okay, sorry. Test 1 is right here, okay, on the left side. And then this is the bell graph for test 2. This is the bell graph for test 3. Now, these are all beautiful bell graphs. If you are a statistician, this is quite a beautiful bell graph. But how do we reject or fail to reject? So, let us now compare now. Test 1 versus test 2, because remember what we want to see is whether there is no difference. So reject it or fail to reject. So the mean comes down to 0.4 when we compare test 1 and test 2. The standard deviation will be 1.94. And then what happened to the, we actually do a T statistics, which in this case we it might be useful, it might not be useful, but what we were targeting was the p-value. So the p-value is 0.008. Now let us look at test 1 versus test 3. The key here is the p-value is 0.7959. When we compare test 1 versus mean, remember our comparison is whether there is physical and no physical. So it's between test 1 and the mean of test 2 and test 3. Then we get 0.0255. How do you reject? You reject if it is more than, that's what the asterisk here is. You reject if it is more than 5%. So let us take a look now. So sorry. So I mean to say that we fail to reject when we compare test 1 and test 2. We fail to reject when we compare test 1 versus the mean. So here, let us have some discussion first. When you look at test 1 and test 3, it revealed that the p-value is higher than the significance value, which is 5%, which implies that there was no significant change, meaning to say that we fail to reject. So we only reject if it is more than 5%. Now let us look at test 1 and test 2. The p-value is it should be, this one really sorry, I should have corrected the slide. I realized this mistake before this, is versus the means of test 1 and test 2. Again, it is less than the significant level, hence, it is more than, it should be more than, this one should be the one that changed, more than, so that's why we reject it. Okay, mean to say that it is not enough evidence. There is enough evidence to show that there was significant change in the mean difference in the students' performance. Now, when we compare test 1 versus the mean, test 2 and test 3, it is lower than the p-value. So it is the same conclusion as for test 1 versus test 2. Test 1 versus test 3. Hence, based on this result, it is evident that conducting physical teaching followed by a test and online teaching followed by a test gave a significant impact to students' performance. In fact, there was an average increase of 0 when we compare test 2, when in fact there is an average increase of 0.4 and 0.2 from the results of test 1 and test 2 when you look at the mean. Let us go back again, this one. So when you look at the mean, so means that there is an increase. Generally, there is an increase in the mean. Now, what can we conclude? Does it matter? We take the test 1 versus test 3, test 1 versus the mean of the mean of test 2 and test 3. So the question that we wanted to ask was, does it matter if physical classes in blended learning or without physical learning in a full online learning environment? The answer is most likely no. However, remember just now a lot of you put the answer depends. I want to make it very clear now. In Java's case, these students have been to physical classes when they are in their first year. Meaning to say, introduction C was done with physical class and physical lab. In my second sem, they did first again physical class and then in a lecture and a lab. Then they joined a Java class. Now I want to all of you yourself now to put yourself in that environment. If you have the foundation, you move on to an online learning now. Most likely you are able to, there's still a learning curve there. Example, now you decided to do Arduino or you decided to do Python or any of those R program or something that you've never done before, there definitely is a learning curve. But because of the foundation, most likely fully online will not be that hard. So here, besides the test performance, the students' feedback was vital. So it is very important to constantly get feedback from the student, which we tried to through the chat and the online discussion. Okay, now we need to thank all this, and then today we need to thank Cam. And then if you got any questions, feel free to ask me now. I will check the chat after this. But before we continue on, I want you to think of this question. Now you are a lecturer now. You are going to pick up a new programming language. What do you think will help you learn better, programming to learn better? Okay, all right. Now, so another suggestion, all of you that are teaching your first year student, the same lecturer, you have a group of lecturer doing C programming. All of you can come together now, and then you can think of something to do. And then based on this same group of students, it's just a suggestion. And then you move on to the C++. Again, based on this same group of lecturer, the same group of students, you can propose a certain learning methods, and then you can actually compare the results in this way, and then most likely you can write a paper about it, and then consider a education paper. Okay, so if you got any question, feel free to ask me. And then all those tools like H5P, there's a lot of videos on it, and then on actually done done a workshop on it, and then like all those eLEAP, like you got the snake and ladder and all these games, all these things are available in your eLEAP, and then you can get feedback from the student even in the middle of the class. All this is there available for you. Okay, so any question anyone want to ask? Am I going too fast, or all of you are totally lost, like have no idea what I'm talking about? There's no question in the chat. Okay. Well, okay. Now, when we do our test 1 and test 2, thank you very much, Irwandi. We also look into the Bloom taxonomy. Of course, we followed the one that is set by the course outline. So the course outline set test 1, the learning objective, or test 1, all the tests has the same CLO. So it has the similar Bloom taxonomy until C5 or something like that. Okay, Irwandi, does that answer your question? It is the
Yes.
same CLO.
Yes.
Thank you very much. That's a good question. Again, this is something when you submit your education paper, this is something that they would look for also. So try to put the test around the same Bloom taxonomy or around the same course outcome, CLO, course learning outcome. Any other question? Thank you very much, Hadi. Okay, I'll be very honest, I've never done an education paper. This was the first time. So when the feedback I got from those teachers, education feedback, we had to sit down and then brainstorm among ourselves. And then we were lucky because the statistician wanted to be with us. Okay, so if no more question, all of you, I hope all of you gain something from this. I didn't want to do a workshop just so that you have here a paper that we presented, but you can gain something that if you decided to write an education paper. Okay, if no more question, then back to the question that just now I asked all of you. If you want to do a new language now, you have the foundation, what do you think will help you pick up the language better? Now, why this question is important? Because if you are teaching programming, that is what the student is looking for. Okay? So if no more question, thank you very much to all of you. I really appreciate all of you attending my sharing. Okay? Thank you. I will switch on I will share the QR code now.
Dr. Pimping.
Yeah, Wandi, you just share apa-apa you need because you are also one of the you're also one of the yes.
The question that you posed just now, you require us to answer kah? Give feedback?
You can give feedback. I'm more than happy, but then again, at the same time, I know ada yang malu kan nak simpan sendiri kan. Okay, if you want to share, just feel free to share. What do you think if now you want to do a programming language, what would help you pick up the language faster or better?
Okay, if I echo.
Oh, yeah, sorry, I will switch off my mic now. Switch off my mic
Okay.
now.
If I'm learning about programming, I guess my preference will be working straight away with mini problems lah, mini coding problems. So so more on a hands-on kind of learning lah. No need for me to focus on the theory, but more on the solving small problem. That will be my preference lah. Thank you, Dr. Tamiping.
You make a really good point here. What as once you have the foundation, okay, have to be really careful. Once you have the foundation, you want to start doing things, but in a very small scale. So that's why the bite-sized learning comes in. You want it to, that's a very good point. So those that already moved to the students, you know that the student has foundation. When you're doing web-based programming or any R programming or any other programming, consider to give this what Dr. Irwandi has said, consider to do this in a small scale hands-on problem to the students so that they can it's the same thing. What you need is what the student need also. So small scale so they can learn better. Okay, thank you very much, Dr. Irwandi. Is there anyone that wants to share? I purposely do this as informal as possible so that everybody can have a relaxed environment to share how they can help students learn better in their programming. No more? Let me look at the chat, huh? Where is my chat? Okay, if nothing else, and then if you have taken your attendance, thank you very much. If you need the paper, just feel free to tell me. I'll be more than happy to share with all of you. And then I want to have a special thanks. Just now I thank the faculty already. I want to have a special thanks to my co-authors, which is Irwandi, Amelia, Sarah, and Steph. Thank you very much.